Hey girls, welcome back. This video is building on what we learned about slope and standard form of linear equations, and we're just going to learn more about a different form to write linear equations in called slope-intercept form. This is another form to write linear equations, like I said, and the way that it's written is y equals mx plus b, where m is the slope and b is the y-intercept. Same as in standard form, x and y are the variables in the equation. So if you are trying to write an equation in slope-intercept form, sometimes they'll just straight up give you the slope and the intercept. Let's take a look at example 1. It's telling you to write an equation in slope-intercept form for the line with a slope of 3/4, or 3/4, and a y-intercept of -2. Then graph the equation. Remember, the slope tells you the m, the y-intercept tells you the b. So in the equation y equals mx plus b, you're going to replace m with 3/4 and b with -2. 3/4 times x makes 3/4 x, and then we know that adding a negative can be simplified by subtraction. Now, not only do we want to write the equation in slope-intercept form, but we also want to graph it. Remember, when you go to make your graph, the slope is telling you the change in y over the change in x. So let's take a look at what that is going to look like on a coordinate plane. If you're trying to graph y equals 3/4 x minus 2, the first step is to plot the y-intercept of -2. So on the y-axis, put a point on the -2. After that, you find another point based on the slope. So the change in y is positive, the change in x is positive. I would always treat it as if it's positive, you go up. If it's negative, a negative number, you go down. So if it's positive, you're going to go up. So up 3, 1, 2, 3, because the change in y is 3. So on the y-axis, you have to go up 3. And then the change in x is 4. So that means you have to go to the right 4. If it's positive, you're going to go up and right. If it's negative, you're going to go down and right. Either way, you can check your answer by thinking about how a positive slope has to make a line that's increasing or going up. 2 points is enough to draw a line, but if you wanted, you can repeat that slope again. Up 3, right 4. Up 3, right 4. And you could keep making more and more points that are all on this same straight line. Now, if you wanted to get to a different point over to the left, you have to make sure you follow the straight line. So instead of going up 3, right 4, you could go flip that over, down 3, left 4. That'll land you on that exact same straight line pattern and get you another point on your graph. Now try the practice problem. Write an equation with a slope of -1/2 and a y-intercept of 3. Here's what the final answer should look like. Now see if you can graph it. Here's what that's going to look like on a graph. You put your y-intercept on 3, and then you follow the slope. -1/2 means you're going to go down 1, right 2. So the negative tells you whether to go up or down. The positive or negative tells you up or down. And then the bottom number tells you how far to move to the right. I would just always stick to up or down, and then on the top number, and then the bottom number, always go to the right. It'll just keep it easier. But like I said, you can always double check a negative slope should be going down on the graph. You could keep repeating that pattern as many times as you wanted. Like, for example, if you wanted to find the x-intercept of this equation, you could keep repeating that pattern of the slope until you hit the x-axis. You could tell that this has an x-intercept of +6. You could also use the graph to make a table if you needed to for whatever reason. Remember, if you're changing between a graph and a table, you just list out the points. Like, for example, 0, 3 is one of the points on the graph. 6, 0 is one of the points on the graph. Tables are sometimes helpful for making graphs as well. Like, let's say you weren't sure how to graph this based on the slope and the intercept. You could always pick numbers to plug in like we did in the first lesson of this chapter. Like, let's say you picked a 2 and plugged it in for x. If you plug in a 2 for x, you would end up getting 2 for y. That's why there's a point at 2, 2 on the graph. Okay, let's do another one. This time, though, it's graphing a linear equation from standard form. So we've already done this a little bit. We looked at graphing 3x plus 2y equals 6 from standard form, but they gave us the equation in slope-intercept form before, and we made a table. We just didn't know it was called slope-intercept form back then in the first lesson. So let's review how could we graph this equation in standard form. How can we figure out the slope and the y-intercept? One way to do this is to change it from standard form into slope-intercept form. So to change from standard form to slope-intercept form, you're going to try to get the y by itself. In order to get the y by itself, you would have to move the 3x over to the other side by subtracting it. And then if you want to get the y by itself, you would have to divide it by 2. Remember, if you divide that by 2, you have to divide every term by 2. Now, it's close to slope-intercept form, but in slope-intercept form, the x comes first, the x term. So we have to move it, like just switch those two terms, put the negative 3 halves x first, and then the positive 3 second. That'll make sure that it's in slope-intercept form. Once it's in slope-intercept form, you should be able to pick out the slope is the m, and the y-intercept is the b value. Given that the slope is negative 3 over 2, that means that the change in y is negative 3 and the change in x is 2. That tells you to go down 3, right 2. And so to graph it, you're going to start out at the y-intercept of 3 and then use the slope to find another point. That would look like this. Start out at the y-intercept of 3, go down 3, right 2. Like I said before, you could keep repeating that pattern in either direction, but 2 points is plenty enough to make a straight line. Here's the correct answer for the practice problem. Make sure you can try that one on your own and get that answer. Here's what the graph should look like for that one. This time it's a positive slope. That's why it's going up or increasing from left to right. And last but not least, we're going to do one more example with graphing a linear equation where it's just a y equals negative 3. If you have just a y, not an x, remember we talked about in standard form, if it's 0x, that's what makes a horizontal line. So if you wanted to write that in standard form, you would put 0x plus y equals negative 3. But in slope-intercept form, it's going to look like y equals 0x minus 3. So the slope is 0, the y-intercept is negative 3. On the graph, here's what it looks like. Every single point has a y value of negative 3. So the y-intercept is negative 3. It hits the y-axis on negative 3, and then it's a slope of 0. So it goes up or down 0, and then it moves to the right as many points as you want. So that's what creates that horizontal line on the negative 3. And no matter what the value was here, that's where the horizontal line is going to be. Since this one was a y value of negative 3, that's why the horizontal line is hitting on the y of negative 3. All right, hopefully that made sense to you guys about slope-intercept form and how it connects back to standard form. It's just another way to write equations, and then you can also use it to graph the lines a little easier because you can tell what the slope and the intercept are from the equation. All right, next we're going to talk about modeling real-world data with linear equations, so we'll come back to that in the next video or the next time I see you. So make sure you ask any questions and let me know if you are confused on anything here so that we can move on and learn another topic. See you guys soon. Bye.